All right, another question that we're interested in, which is actually more difficult, is that we found that in some neurodegenerative diseases, some people have changed in personality. Somehow they become more stubborn, like in Alzheimer's disease, Parkinson's disease. We're interested in why this is the case. And also in aging, people claim that when we become old, sometimes we are less flexible in our thinking. It is actually rather tough questions. So again, we go back to our animal models. So apart from being very good athletes, actually laboratory animals are actually very smart. The more I deal with animals, the more I learn about this fact. So in this case, what we did is that we trained the animal to learn a rule, a particular rule to get food reward. For example, in this case here, we use a visual cue to guide these animals. We put the food in the arm with the visual cue here. So this mouse would directly go to that arm. If we change to the other side, for example, in this case, we put on the left, our animal, after training, automatically will go to the visual cue area, right? So this is one rule. After we train this animal full to this rule, then we change our rule. Our rule in this case is that, okay, ignore the visual cue. No matter what, just go to the left. So in this case, this animal will ignore the visual cue but go to the left to get the food. So maybe it coincides with the visual cue, but sometimes it didn't. So in this case, we train the animal to learn one rule, and then we force it to master another rule and see how flexible or how many mistakes this animal will make during the switching. So after that, after a series of work, we finally worked out that there seems to be a particular brain circuit in the brain, including a cortical area like the prefrontal cortex, subcortical areas, the nucleus accumbens, and then a very important source of information is from the dopamine projections from the midbrain, in this case from the ventral tegmental area. So we think that this circuit is very important in mediating the so-called cognitive flexibility, which is the technical terms for whether you are stubborn or not stubborn, okay? And we think that in Parkinson's disease, maybe it's due to the loss of dopamine that causes some decreases in the cognitive flexibility. So these are just two examples. Again, we published the paper in a rather good journal. Now, okay, I hope that I have convinced you some of these excitements and some of those good things about studying neuroscience. So if you are interested, okay, the last question is, how can one become a neuroscientist? Well, I would say that anyone have some training in science, engineering, medicine, or even some other outside field can become a neuroscientist. So no matter whether you are majoring in your universities, neuroscience, biology, medicine, biochemistry, physics, engineering, you name it. As long as you enroll a program, say a PhD program in neuroscience or neuroscience-related subject, and you get a PhD, a doctoral degree in this area, then you become a neuroscientist. And usually, a neuroscientist will do some postdoctoral training. In other words, after getting the doctoral degree, one will still need to do a few years of research before maybe a university can hire you as an assistant professor, and then maybe an associate professor, and then finally you become a professional neuroscientist. So this is how I became a neuroscientist myself. All right, so before I stop, I think I would like to use this very last slide to pre-welcome those finalists of this brain break competition. I don't know how many we will have, maybe 5? 6. Oh, okay. So I would welcome in advance those finalists to our Zero Choice Neuroscience Center at Chinese University. This picture was taken last year. A few of the finalists came here. We talked a little bit more about the brain and also the projects and also facilities in our center. So I think I'll stop here and I'll pass back to Michael. Thank you very much.